Now we're going to try and understand why the ratio tests work, because it's quite strange. Because if you look at this series, compute this value here, it equals 1. So when it equals 1, the test is inconclusive. But we've seen in the past that this series, for some reason, it diverges. If you look at this series, 1 over n squared, if you compute this value here, if you compute this value, it happens to be 1. Now, when it's 1, the test is inconclusive. But then we've seen in the past that this series will converge. So when it equals 1, it's inconclusive. For this example, it diverges. When it equals 1, in this example, it will converge. So when it's 1, we can't determine anything. But then for some reason, the minute you know this, n plus 1 over an, and then take the limit as n tends to infinity, the minute we know that this thing here is less than 1, then the minute we know that this thing here is less than 1, then we will immediately know that the original series will converge. So it's quite strange in that the next term divided by the current term, if it's less than 1, then we will immediately know that the original series will converge. So in this video, well, not in this video, but now we're going to try and understand why this works. Why is it that, well, the minute we know that it's less than 1, the minute we know this to be less than 1, then we will immediately know that the original series will converge. Okay, so in the past we looked at the absolute sign, but in this book, they're just looking at the positive term, but both methods work. Okay, so it doesn't. So you can look at the absolute sign, or you can impose a condition that everything's positive, and then you can ignore the absolute sign. They're both essentially the same. Okay, so now I'm going to give you a brief explanation, and then in the next video I will take it step by step. So the brief explanation. Well, have a quick read at the proof first. So this here's a theorem. This here's your theorem. This is your proof. Have a quick read, and then in the next video I will take it step by step. But now I'm just going to give you a quick explanation. First, I need you to realize that a geometric series, if it's less than 1, then it's going to converge. It actually converges to this. So just know that with a geometric series, if the common ratio is less than 1, then you know 100% sure that the series is going to converge. So I'll require you to know this. Okay, and then realize that, remember, with a definition of limits, if you have a function, if a function has a limit of capital L, it means that, remember, this is us going back, this is revision, you should know this, definition of limits. If you have a function, for a function to have a limit, capital L, it means that for any given tolerance, any value, any n above capital N, everything above capital N, everything beyond capital N, all the values of f of x must fall within the tolerance of L, within L plus epsilon and L minus epsilon. So this is our definition of limits. But the idea behind this, the idea to understand why the ratio tests work is for us to so this is our sequence. The idea, the trick behind it is to impose a geometric series which we will know that always will be above the original series. So we are trying to investigate this series. The trick to understanding why the ratio test works is to trap a geometric sequence which we happen to know is always greater than what we're trying to investigate. So we are going to try and trap a geometric sequence, but we know that this geometric sequence will always be above what we're trying to investigate. Now, with a geometric sequence, we know it's going to converge with a geometric sequence. So therefore, what we're trying to investigate will also converge. So that's the idea. The idea is to trap a geometric sequence, and then we know that the geometric sequence will converge, and the geometric sequence being always above what we're trying to investigate. Therefore, what we're trying to investigate will also converge. So that's the idea. That's the idea. Okay. I will explain it step by step in the next video.